Hi, I'm Bob Van Til, Chair of Industrial and Systems Engineering here at Oakland University, and welcome to the Product Lifecycle Management Lab in room 568 Engineering Center here in the Oakland University's Industrial and Systems Engineering Department. This room is our primary computer lab for the Department of Industrial and Systems Engineering. It is used by a multitude of courses in our program. Some courses will use it only for a small assignment or two. Other courses will make heavy use of various softwares available in this lab. One of the prime users of this lab is our Introduction to Industrial and Systems Engineering. That course is taken by all engineers in our core program. So we have anywhere from 150 to 200 students per semester going through this lab. Based on the number of 18 computers, this is about a 600 square foot lab. Obviously, we can't bring them all in on set times. So what we do with that lab, and we're running that lab actually, is we run that semi-virtually. These students can actually remotely desktop into these computers and virtually work on the labs. And we'll get a mixture of both. We'll probably, on the simpler labs, a vast majority will do them virtually. And the little bit more difficult labs will give them a higher percentage of students actually coming to work on them here to get TA assistance. It's also taught, we also offer 5 special 2-credit courses that run 7 weeks that are actually taught inside this lab on various Industry 4.0 software, PLM software tools. Those are outlined in our ABET self-study report. And so those particular classes do have a scheduled time where they'll come and they'll spend a couple hours in this lab holding the actual class. It's a very hands-on focused class on various software tools. This lab contains many softwares with a heavy focus on Industry 4.0 software. Some of the tools available on these computers would be the plant simulation software for discrete event simulation, Arena also for discrete event simulation, the Jack ergonomic software from Siemens, Siemens Process Simulate software, which is used for robotics and for manufacturing cell design. PLC software from Siemens is on these computers, along with Minitab. MindSphere IoT software from Siemens is also available on these computers, along with other general tools such as Office for presentations and writing reports and making spreadsheets. We are working also to add SAP software to this lab for our ERP course. Now we're going to take a look at some of the Industry 4.0 prime software tools we have in this lab and use in various classes. The first one is our discrete event simulation tool, Plant Simulation. This is from Siemens. It is a very popular tool in industry. General Motors and FCA, this is their prime design tool, and Ford extensively uses it also, along with a lot of other non-automotive industries. What you're seeing running here in that video is a student project last year from our PLM Applications Throughput Simulation course. That still picture there is the conveyor system located next door in our Scharf Computer Integrated Manufacturing Lab. This 3-dimensional running of the animation, mostly for display purposes, and then it'll switch back to the 2-dimensional version where real engineering work goes on in discrete event project. Again, this tool is used everything from our EGR 2600 course to give our sophomore level engineers an introduction to some advanced tools and some concepts they're going to see later. We use this through several other courses up through the capstone design course. In fact, this semester, 2 of our capstone design projects at Broza and at Siemens are using this tool right here. The next tool we're going to take a look at is our ergonomics tool, Jack. Now this particular animation shows a nice animation of the capabilities of Jack. Jack is a full ergonomic tool. It'll do stress analysis on all the joints. So as this mannequin is doing this process, you can measure stresses on wrists and shoulders and elbows and back and analyze that for repetitive stress or even disruptive kind of injury because you exerted yourself. This will also load in and do collision avoidance. And so that is a CAD front end of the car. As the mannequin is reaching down in there, this will tell you if that gap is too narrow and that you're actually passing your arm through metal. And of course, the mannequin can be male or female. And this is about a 50% male here. You can change that to a 95% male and the mannequin will grow in size, or 5% female and it'll change to a female and decrease in size. And you can analyze them for various behaviors. So we use this in several courses. Again, the students are introduced to this tool in our sophomore level EGR 2600 class, where they really aren't doing ergonomics, but they kind of see the tool, they get to play with it a little bit, they get a look ahead at some of the future courses. Heavily used in our ergo course, and we use it some in our senior design projects. Third tool we're going to look at is not as heavily used as the first two. This is Process Simulate. It's used for robotics and manufacturing cell design. This particular animation is from a senior design project last year run at JR Automation. We had a team of 3 students on that project. They designed this cell. It is going to go into General Motors plant, working with JR Automation engineers and managers. What you're seeing is the robotics portion of that cell running here. This tool will do full collision avoidance. You can play around, design the whole cell, do timing, all your engineering analysis, and then it'll actually generate the robot programs that can then be downloaded and actually run the robots. This project as a capstone actually had a couple more issues involved in it that you don't see in this video. On either end of the cell, the load portion and the unload portion, this particular plant actually had manual load and unload. And so this team also did a pretty extensive ergonomic analysis of the operators loading windshields on the right-hand side of the cell and unloading them from the left-hand side. Well, obviously, this isn't a hazardous lab. We still take safety extremely important to all our labs. As are all our other labs, it requires access. It's a locked lab. This particular one, because of the computer nature, has ID card access for the students. And of course, we also post emergency information for the students. An emergency management guide that would contain all the procedures involved, what to do in a tornado, what are the contact information, what to do with the lockdown, evacuation, and other emergency situations. And so that is also posted in this and every other lab.